In this pod, we're going to investigate the effectiveness of different materials as thermal insulators. Before we start, let's revise how thermal energy is transferred. Thermal energy will move from a high temperature to a low temperature. There are three methods of thermal energy transfer: conduction, convection, and radiation.
Conduction is thermal energy transfer in solids. The particles in solids are closely packed and cannot move around. When they gain energy, they vibrate more vigorously. They pass on the vibrations to their neighbouring particles, and so the energy is passed through the solid.
Convection occurs in liquids and gases, that is, in fluids. In fluids, the particles are free to move around. When they gain energy, the particles move around faster, so they get further apart, which results in them occupying more space. The hot part of the fluid becomes less dense and rises. The space that is left is filled by colder, denser fluid. This is energy transfer by convection.
Radiation is energy transfer by infrared waves. All objects above absolute zero in temperature will emit infrared waves. If an object is hotter than the surroundings, it will emit more infrared waves than it absorbs, so it loses energy and its temperature will decrease.
Thermal insulators are materials which reduce the transfer of thermal energy stores by conduction. In this investigation, you're going to test different materials to establish how effective they are at reducing loss of thermal energy by conduction. You'll need 4 copper containers of exactly the same size, 4 thermometers, and 4 lids made of the same material, cardboard, with the same thickness. You'll also need 3 insulation materials. Some materials that you could use are bubble wrap, corrugated cardboard, and cloth. Set everything up as shown. Remember to leave one container uninsulated so that there is a control to compare the other results with.
Each container is filled with the same volume of water at the same temperature, just below boiling point. Remember to take care when using hot water. Stir the water and take the temperature every minute using the thermometer. Record your results in a table. Continue doing this for 20 minutes.
We can now plot graphs of temperature against time for each container on the same set of axes. The graph with the steepest line shows the highest rate of temperature decrease, so has the highest rate of energy loss. This is the worst insulator. The graph with the shallowest line shows the lowest rate of temperature decrease and the lowest rate of energy loss. This is the best insulator. Good insulating materials often contain little pockets of trapped air, like bubble wrap or foam.
You could do another investigation to see how the thickness of the thermal insulator affects the rate of energy loss. This time, use the same material for each of the 4 containers, for example, bubble wrap. Put different numbers of layers of bubble wrap on each container. Your control container will, again, have no insulation, so we can compare the effects of different layers of insulation to no insulation. On the other 3 containers, you could put 1, 2, or 3 layers of bubble wrap.
As before, add the same volume of hot water at the same temperature to each container. Stir the water and take the temperature every minute for 20 minutes. Plot graphs of temperature against time for each container on the same set of axes. The shallowest graph has the lowest rate of temperature decrease and the lowest rate of energy loss, so is best insulated. You should find that the more layers of insulation you use, the shallower the graph, showing a lower rate of energy loss.
In both of these investigations, there were lots of variables that we had to control, that is, keep the same, for all 4 containers, so that they did not affect the rate of energy loss from each container differently. These control variables were volume of water, starting temperature of water, shape, size and colour of the containers, and use of the same lid on each container.